This is the first of 3 CEOs of different companies who are our school alums who are coming to give these Centennial Seminars. One today, one next week, and the one following week. And they will all be on these Thursdays because their schedules are very tight. So instead of Tuesdays, these are on Thursdays instead. Both next ones as well. Let me briefly introduce to you Mike Graff. Mike received his bachelor's degree from IIT Chicago in 1977. Then he worked for a year with Amoco as a research engineer, and then in '78 joined chemical engineering for his graduate program and received a master's degree the next year in '79. And then he went on to work at Amoco Oil Company, later with Amoco Chemicals, eventually rising to become the president and CEO of BP Polymer Americas. This was during the period 2001 to 2004. At that time, he had a big choice to make, move to London or stay in the US, because BP is based, of course, over there, as you know. And he decided to stay for various personal reasons, and then started his own consulting company for a couple of years, and then took on a position with the company that he's with now. He was taken up and selected as the president and CEO of Air Liquide USA in 2007. So just briefly about Air Liquide. Air Liquide is the world's largest industrial gases company. It employs throughout the world around 48,000 people and has about $20 billion of sales. It's based in Paris. Now the US part, which is what Mike Graff heads up, has about 4,800, I guess exactly factor of 10 lower employees, and has sales which are not a factor of 10 lower because they are 3 billion now, not 2. And so he's had this position since 2007-8. So a large company, very large company, the largest in the world in industrial gases, and that he's had other promotions even since then. How far can you go after being CEO? But yes, indeed. So what he did have is that he's also in charge actually now of not only USA but also Canada. So this makes it North America, CEO and President for North America, Air Liquide. And then in addition, he has become a member of the executive committee, which is a handful of people who are now at the very top end of the company who oversee the entire operations as being executive committee members, or essentially board of directors for the corporation. And so for this reason, he has to go to Paris, for example, twice a month. And it's a hardship thing. First or twice is very nice always, but then when you have to do this twice a month, it's not quite so fun after a while, even if you're traveling in, let's say, first class, but it's not so easy. In addition to all of this, Mike has provided what I would call exemplary service to the School of Chemical Engineering. So for example, he was on the executive committee of Industrial Advisory Council for a number of years until 2004. And then he was also, during the same period, from 2000 to 2007, we had the campaign committee for the School of Chemical Engineering, which raised the funds for this addition first and then for the renovation. He was a member of that, what was called Champions of Excellence Campaign Committee, that raised the funds along with the school administration and others, mainly alumni and school. And then in addition, since last year, he has been serving the school as a member of our Centennial Planning Committee. Now to have a person of his level be available, so we've had now 10 planning meetings, each are 1 hour long. I think he's attended about 8 of them, by telephone of course. But to take this kind of time for school service, being in the position that he has really been extraordinary, and a great, great pleasure to have Mike as a member of the school's Centennial Planning Committee. And so he is one of the, so we selected him as Centennial speaker when he was not in one of those meetings that he was attending himself. So the rest of the committee recruited him to be one of the speakers. Of course, he could not be present at that time. So now without much ado, because in fact he has to leave here around 4:15, the reception will be after the seminar at 4 o'clock to begin in the atrium. So Mike's going to speak to us about a rather large topic, which is very important, of course, not only for our country, but for the whole world. So Mike, please come and wait yourself.
Thank you, Arthur. Thank you, Arvind, and good afternoon to everybody. Thanks for taking the time out of your busy schedule. I know for many of you, you're getting close to finals, and there's plenty of pressure and stress to go ahead and get ready for those. Thanks for taking the time. As Arvind said, I'm the president and CEO of American Air Liquide Holdings. And what I thought I'd do is just take a minute and just kind of share just briefly a perspective on who Air Liquide is. We are the largest industrial gas company in the world. We actually operate in 81 countries now around the world. And our 48,000 employees not only spread across all those countries, but we serve a variety of different industries. As the slide says, we're the world leader in gases for industry, health, and the environment. And when you think about industrial gases are pure oxygen, pure nitrogen, pure argon, pure hydrogen, xenon, krypton, for just about every industry that's out there. So whether that's commoditized industries like steel and glass, refining, chemicals and plastics, CO2 for enhanced oil recovery, specialized gases now that can be used for fracking to produce natural gas with shale rock, highly specialized gases for foods and pharmaceuticals production, electronic specialty gases, highly specialized chemicals to produce semiconductors and memory chips. A lot of work that we do in the healthcare space, medical oxygen for hospitals, therapeutic gases, new concepts for anesthesia, and we're also very engaged in the space programs, both for NASA as well as for the European Space Agency, supplying the hydrogen, the oxygen to fuel the rockets, the nitrogen to inert the gas pads, and for the European Space Agency, we actually fabricate a lot of the various components of the rocketry as well as the fuel tanks and that sort of thing. So what I wanted to do was spend some time today and really engage you in a discussion, not just make a presentation. And really the concept here for me was to engage you in a discussion more about you and where are you going and where are we heading. If you think about the evolution and this celebration of 100 years of chemical engineering at Purdue, it embodies a number of things that have happened over the last 100 years. Clearly the industrial age was upon us. The volunteerism, especially of young people in the world around us, whether that was rising to the needs of the world around us, serving their countries, whatever the case may be, was there. And I would say that the evolution of the economies around the world and as they grew created lots of opportunity, and I'd like to talk about that. But before we do, I think it's pretty obvious, how many here are chemical engineers or soon to be chemical engineers? Okay. And how many of you got into chemical engineering because you were good at math and science and had an interest in it? And how many of you got involved in this because you thought in the next 100 years you could change the world? Okay. Okay. And that's what I really want to talk about, because if you begin to think about the evolution of the world around us, and you begin to think about, I would say, first of all, the way young people have always stepped up in the time of need. And a little bit of this is a bit US-centric at the beginning, but believe me, we get global as we go through it. Over the course of the last 100 years, when you had the need for help, to fight for democracy, to do the right things, it was the young people that stood up to do that. This is the most famous poster in marketing ever. No matter who it was, no matter who it did, this particular poster, okay, drove 4.3 million young people to go ahead and volunteer for their country in World War I. These same posters drove that kind of concept in World War II. People wanted to step up and fight for democracy. And when the challenge came to step up for other things, it wasn't always about war and conflict. In the 60s, we started the Peace Corps. And it was the young people that stepped up and said, I want to do things for the world around me. It was young people that said, I want to give time, I want to give of myself to create a better world. And this really began to resonate. And it was always young people that kind of drove culturally where we were going with things. And in the 80s and 90s, as connectiveness came about and the evolution of communication and the evolution of who we could be evolved, okay, it was young people that really embraced that really made it take off. And yeah, that's a young Bill Gates in that upper right-hand corner, and no, that's not me with the cell phone that looks like a brick, but I actually had a cell phone that looked like that at one point in time. But the point is, I think it's young people that have always risen to the cause and have always been there to go ahead and create a better world. And really, when you think about our time of need here as we entered the 21st century, I mean, if you looked at the aftermath of 9/11, the way that people stepped up, the way that people contributed, the way that people wanted to donate their time, their efforts to go ahead and try and resolve some of the issues that occurred, whether it was, I would say, contributing to the Red Cross, contributing to areas where they could help. People came from around the country to try and help the people of New York. If you look at Katrina, if you look at the impacts of a hurricane, we saw the evolution of an entire country, an entire world. Look at what happened in New Orleans. And not only give monetarily, but give of their time, give of medical needs, give from a societal perspective to go ahead and help the people. If you look at some of the earthquakes that have occurred, especially the one that happened in Haiti, a country that had little from an economic perspective. And if you looked at the way that the people around the world reached in to help, it was young people that volunteered to go there, to provide the medical service, to go ahead and do anything they could do to help that country. And so young people have always been there to step up in our time of need. Now, if you begin to think about science and engineering in industry, I can't take credit for this quote, and obviously it was an engineer that made the statement, okay? As a matter of fact, Theodore von Karman was an engineer with a specialization in aerospace engineering, and he was also a physicist, so he was kind of dual degreed. But the point here, okay, that it's been engineers that have continued to drive the evolution and have helped create the modern society and cultures that we have around the world. And when you think about the beginning of the industrial age, when you think about all the things that happened, I mean, we can talk about Henry Ford, okay, and the evolution of cars. And in fact, that could never have been enabled if a guy by the name of William Burton, that actually invented the Burton still, actually at a point, he developed that technology. There were 4 operating automobiles in the US. And his technology actually increased the amount of motor fuels that could be produced from a barrel of oil by over 50%. And without that invention, there would never have been an automotive industry. There would have never been that evolution. If you look at the lower right-hand corner, the individual standing next to that funny contraption, that funny still, is Georges Claude. He was the founder of Air Liquide. And in 1902, he commercialized the process to separate the air that we breathe today into its pure components of oxygen and nitrogen. And it was pure oxygen along with acetylene that really created the ability of the manufacturing age to begin to evolve and to create the world around us that we see today. And that clearly evolved over time. I mean, in the late 20s, Alexander Fleming invented penicillin, and a whole new world of medicines and pharmaceuticals took shape. As we evolved through the war period of World War II, we benefited with a lot of the naval and aerospace engineering that have actually created the way that we actually transport people and goods by air today. That evolution continues to pay dividends as we think about the world around us. And in the 50s, we really saw the advancement of electronics. You know, we saw the initial stages of computers. We saw the initial stages of TV. And you know, today with this BlackBerry in my pocket, I have more computational capability than that entire room full of computers. I can watch a show probably with better clarity than you can see on that TV, and yeah, I can do a heck of a lot more things as well. And it's pretty amazing how the advances in technology have actually gone ahead and created that opportunity for us to evolve. And you can talk about the evolution of the highway systems, you can talk about the evolution of a lot of things, and then we hit the 60s. And yeah, I know this picture looks absolutely ridiculous, but there's a point here, okay? As plastics really began to evolve in the 1960s, it kind of started out, okay, as a cheap way to provide maybe dishware and maybe glasses and a variety of other things. And next thing you knew, somebody began to think about how they could take plastics in lightweight cars and how they could go ahead and create better fuel efficiency. And the next thing you knew, they started to develop very high-tech plastics that could go under the hood and begin to replace all the components that had to be made of metal. further reducing not only the weight of the car to make it more fuel efficient, but actually began to go ahead and drive a better perspective in terms of the operation of the vehicle itself. And yeah, I mean, we actually did, out of the polyesters and that sort of thing, produce the pastel leisure suits as well. So that just goes to show any technology in the wrong hands can be a problem over time. But the bottom line is we began to see this evolution take place. And for some of us in this room, as you began to think about the true impact, the true evolution of technology, and how that influenced us to become engineers, I know for me, one of the important events in my life was the whole space program. And being in grade school and hearing President Kennedy talk about how we were going to put a man on the moon. And this opened the door to science and engineering in a way that really got me excited. And I followed it all the way until that warm evening in 1969 as man first set foot on the moon. And that engaged me, that excited me, the concepts of engineering and science and all those capabilities. And as we begin to think about where we are today, in the further evolution around broadening communications, this connectedness, you know, as you think about, for those of us that had that PC that wasn't connected to anything, it was just a computational device that was in your office or in your living room or whatever the case may be, and a lot of people saying, now why would I need that? Okay, I can store some information, I can use it as a word processor. And then somebody invented the killer app that's hit the world. The net. And all of a sudden, the whole world was connected. And all of a sudden, at a push of a button, you can Google and you can learn anything about anything, any place in the world you want. And all these things were created by engineers, by scientists that were thinking about how they could do things in a better way, how they could create new opportunities. Now, I asked you early on how many of you actually got into engineering, chemical engineering specifically, to change the world. And my supposition is in the next 100 years, we are going to see more challenges and more opportunities to shape the world for the better with the skills and the competencies that you possess and that you will bring to the world around us. And I think one of our challenges is, as we think about this, how do we encourage others to make those kinds of career choices? I mean, if you look at this, the number of students, I believe, that are entering and graduating with engineering degrees have been stagnant since the 70s at roughly 60,000 in the US. Stayed stagnant, hasn't moved, hasn't changed. I've got two kids now that are in college, and neither one chose to be an engineer. Okay, and I talk to them and I talk to their friends and I try and get them invigorated. I try and understand why not. And they've taken very serious courses of study and those kinds of things. But the bottom line, a lot of people see engineering as tough and it's difficult. They see everything we have to do, and yet when you think about this, okay, and you think about what we can do, what we have demonstrated we can do in the world around us, how do we go ahead and not only utilize our skills and our competencies and our capabilities to not only do the right things today, but encourage and entice others to go ahead and study engineering to be prepared for the future? Because if you think about the challenges facing the modern world, if you think about the challenges of energy, and I'm talking about clean energy now, I'm talking about creating an opportunity from a sustainable perspective to meet the ever-growing energy needs of the world, and yet recognizing that we have to deal with this in a sustainable way. Reducing greenhouse gases, creating a very different CO2 footprint. When you think about the environment, what can we do to go ahead and not only manage energy, but imagine all aspects of what we do in the modern world, and to do that in a way that recognizes the needs of the environment. I mentioned communication before, and that connectedness is critically important. We enjoy that. There's many parts of the world that don't. And how do we go ahead and get them connected and provide those opportunities for them to be a part of the evolution of the world around us? When you begin to think about the needs of all cultures in terms of food, and in terms of water, and in terms of better health care, okay, how do we meet the growing needs of the world's populations? How do we create better health care? How do we create the opportunity to feed the people in the world as we grow and we evolve? Now, okay, there's been a lot of different approaches to this, okay? One approach, and it's important, is our behaviors, okay? Very, very famous chat with President Carter back at the time of the, I guess it actually would have been considered the second oil crisis, but it was in the late 70s. And the concept was that we were going to save our way to energy prosperity, that we were all just going to turn down our thermostats, we were all going to just use a little less energy, we were going to change our behaviors a little bit, and we would be fine. We would reduce our dependence, at least in the US, on foreign oil. Now, the reality is, our energy needs continue to grow monumentally. Every time we develop that next new computer, every time we think about the kind of things that we want to do, the things we embrace in modern culture, in reality, they require more energy. We work to be more energy efficient, we work to do things in a better way, but we can't only save ourselves to prosperity. But behavior is important, right? It's not just tweaking a thermostat, maybe it's driving a hybrid. Maybe it's thinking about driving a smaller car. Maybe it's about making better choices in how we use our energy, but it's not the only way that we will go ahead and manage our way to a successful future. I think that the reality is, when you think about all aspects of this, it's going to be breakthrough technology. It's going to be breakthrough technology in every one of these areas. The kind of technologies you might be working on today, the kind of technologies you might work on in the future, the kind of technologies you might collaborate with others from around the world to go ahead and develop and to evolve, to go ahead and create that basis for the world around us. And as you began to think about this, okay, real life examples, real life components of what is going on today to prepare for that, okay? Obviously, one of the first things has to do with just meeting the energy, the electricity needs, the power needs in the world around us, okay? And one of our challenges, I mean, we've just seen what's happened, okay, in Japan, and the concerns about nuclear power and some of the things there, okay? There are some countries like France, okay? 97% of their power is generated from a nuclear perspective, okay? But in reality, as we think about the energy balance, as we think about how we can go ahead and manage ourselves successfully and diversify our energy needs around the world, you've got this balance of nuclear power, you've got oil, you've got natural gas, you've got coal. And we'll get to some of the other more far-reaching opportunities from an alternative energy in a minute. But when you think about that, coal is something that's highly prevalent. It's highly prevalent in the US, it's highly prevalent in China, it's highly prevalent in Australia, and in many aspects, okay, it is readily available for use today. And yet we know when we burn coal, we have a huge CO2 footprint associated with that. So how do we go ahead and find a way to burn coal and capture the carbon dioxide emissions and avoid, okay, creating an additional problem from a CO2 perspective, from a greenhouse gas perspective? And so there's a lot of technology. We're involved in that as a company. As a matter of fact, we have 2 projects that are underway right now in the state of Illinois, taking Illinois 6 coal, one where we gasify it. We have a grant from the Department of Energy for roughly $1 billion in consortium with Babcock and Wilcox and Ameren Energy to work together to demonstrate we can take an old, aging power plant, convert it to this highly specialized oxy-combustion technology, burn that coal with these specialized burners using pure oxygen, recover the carbon dioxide, and sequester it in a saline aquifer that runs across the Midwest. Now, this is a test program. This has never been done before on a commercial scale, okay? But these are the kind of things that engineers today are already developing and already working and already finding a way to make happen. We see around the world. We see in China, we see in Australia, we see in southern France, we see here as well in Illinois and other states where we're looking to see how we can gasify coal and turn that coal into synthetic natural gas, turn it into power, turn it into methanol as the basis for chemicals, and do it, again, in that same way by capturing the carbon dioxide, by using pure oxygen to go ahead and fuel the opportunity, and to create all of our needs without the CO2 footprint. Another key area that we will continue to see evolve, and we will continue to see, I would say, gain from an environmental perspective while meeting the needs of the future, is transportation. There's been a lot of discussion over the years about basically utilizing hydrogen in a hydrogen economy to meet the transportation needs in the world around us. And about 10 years ago, a lot of companies were really big into this. They were trying to drive hydrogen. They were trying to do a variety of different things. And yet, when you look at how this has evolved and how it's played out, many of those companies have started to back out of it because the difficulty is, how do you produce hydrogen in a sustainable way? How do you produce hydrogen in a way that, let's say, doesn't create a lot of CO2, for example, steam methane reforming? And so today, and we've actually demonstrated this both in terms of the recent Winter Olympics in Calgary and now commercializing it with companies like Coca-Cola and Walmart, we have now developed and demonstrated that from an economic perspective, at least in small quantities, you can utilize hydrogen and utilize fuel cells to fuel forklifts, the trailer tows around airports, a variety of other things, and do that in a way that doesn't create any CO2 emissions and actually provides an economic benefit to the company. So no government intervention, no government subsidy. This is something they want to invest in, okay? And we've got to think about the future, and we've got to think about how do we go ahead and create that environment where in the future, okay, we can begin to drive alternative energies to go ahead and meet the needs that we forecast in the future. So we've all seen the wind farms, and we all know photovoltaics is an opportunity, and it actually works today in isolated regions around the world where they have no other choice. But our problem is that something like photovoltaics doesn't have grid parity. We cannot produce the power using photovoltaics at a price that's equivalent, okay, as what you would see from power produced from large coal systems, natural gas systems, or even from nuclear power. Now, the question is going to be, who among you or who out there is going to create that photovoltaic cell, that next generation, to go ahead and drive this to the point where we can get grid parity? And as you develop that, and it's going to happen, right? We saw the vacuum tube evolve to the transistor. We saw the transistor evolve to the semiconductor. And it's completely changed the way we communicate, the way we think, the way we manage our world, okay? And that same thing is going to happen with photovoltaics. There's no question in my mind. The question is, how do we get there? And it's going to be engineering and engineering solutions that are going to drive that kind of an opportunity. And then the next question is going to be, coming back to the hydrogen piece of this, okay, so if I start to derive more and more and more of my power from the sun's energy, how do I assure that I can rely on that source when the sun goes down? And it's something that Rex and I were talking about earlier, a systems approach to how do you go ahead and think about our energy needs and how do you manage that grid. Now, if you go back to what I was talking about before with hydrogen, and you begin to think about creating power as a result of photovoltaics, and if I find the way to do that in an efficient way, then any excess power I produce, I can use to hydrolyze water. I then produce pure hydrogen. I can store that hydrogen at night. And then at night, I can go ahead and I can produce power. And the only byproduct is I utilize that hydrogen is going to be water. And so now we create this sustainable opportunity for, I would say, not only the transportation needs that we just talked about, but also to meet the power needs of the grid. Another key thing is connection. And there's a concept out there that says somewhere down the road, we will need one laptop, one communicating device for everybody in the world. How do we get to that point of connectedness where the whole world can go ahead and enjoy the things we enjoy on a regular basis? They can communicate, they can learn, they can evolve. And if you think about it, it's not only an opportunity from a science perspective, it's not only an opportunity from a cultural perspective, but if you look at a lot of the things that are going on in the world around us, and the fact that people are communicating from a societal perspective now with cell phones, areas of the world that we're not allowed to have communication with the external world, that we're not allowed to go ahead and share and dialogue on things, suddenly have that opportunity because of these kinds of communication capabilities. Another key breakthrough that a lot of people think about and a lot of people talk about has to do with food and water. And I would say that when you begin to look at the needs of the world around us, we may sit here in Indiana and we may have a prevalence of water and food. and that sort of thing. But when you reach out, when you travel the world, and I have that opportunity on a routine basis, you realize that the needs of the world around us in terms of food and in terms of water is in a very different place. And I really believe that as you begin to think about your role and the role of others, as they begin to think about meeting the challenges and the needs, food production, food preservation, as you begin to think about water, water treatment, creating new ways to go ahead and purify water, ways that haven't been thought about before, that you will find you're not only creating economic opportunity, but you're creating the social good for the world around us. Another key area that the world does not have an abundance of is the availability of healthcare, the availability of the medicines they need and the pharmaceuticals they need to meet their needs. And it's probably something that we see the debate on healthcare here in the US, we see the debate in the world around us. And it's an area that is really starting to revolutionize the way we think about the production of pharmaceuticals, the production and meeting the needs of healthcare in the world around us, and starting to rethink from a delivery standpoint how we do that. Just recently, and I was sharing this with Rex earlier, we as a company have started to rethink how you might provide therapeutic gases to be used for anesthesias, as an example. So rather than utilize a chemical-based pharmaceutical to anesthetize a patient who's going to undergo major surgery, we have now demonstrated we can take the air we're breathing right now, separate it into its various components, recombine it in a different way, and take a patient and dial them from breathing the air we're breathing right now into this specialized mixture, and they're fully anesthetized. And they go through major surgery, and when that major surgery is done, we dial them back onto the air we're breathing right now. And within a minute, they're fully coherent, they're speaking with no after effects at all from an anesthesia perspective, okay? Now, a couple key points here, all right? 10 years ago, nobody would have thought that could have occurred, okay? The second point is that in the world around us, if you've ever known anybody that's gone through something like this, okay, major surgery, the anesthesia, especially as you get older, can be as difficult to get over as the surgery itself. And actually, as you get older, it can have lingering effects. But one of the things we learned, something that just came about because some engineers, some scientists were interested. They wanted to understand more about some of the things in the world around us. They recognized that they found that some things we thought were inert, as we all learned they're inert in the periodic table and that sort of thing, once they get inside the human body, might not be so inert. And so something like xenon that maybe was used to go ahead and produce neon lights and maybe insulate glass for windows and those kinds of things, has an active reaction, an interaction with the brain cells, and can do things that we never imagined possible. And not only can be used from an anesthesia perspective, but from a therapeutic basis for other things. And so this begins to open the door to not only a whole new set of technologies from a medical standpoint, but it also creates a more beneficial way to go ahead and deliver that perspective. In the end, okay, the question is where do these solutions come from? In our case, and in your case, it comes from young people like yourselves that have had the opportunity to gain an engineering education, that are going to embark on research and development, are going to embark in the world around us to go ahead and create opportunity. And as you create those opportunities, you don't really realize, I think, as you leave school, how you might impact and how you might not only create opportunity for the company or the institution you go to work for, but for the world around us. And for some of you, you're going to be in a situation where you'll be at the forefront of creating some of these kinds of technologies for the future. For some of you, you will be in a situation where, yeah, you may not only change the world, okay, but you're probably going to create new industries. You're probably going to create new jobs. You're going to create the opportunity for people that do not have a job today to put food on the table for their families. I mean, one of the things I'm proud of in all the places I've been and all the places that I've been engaged in is I've been at the forefront of being able to develop a lot of new industries around the world. And I can point to plants, I can point to companies, I can point to opportunities that were enabled by many things we do that have created hundreds and hundreds and hundreds of thousands of jobs that have led to the employment for people and created the economic opportunity for them to grow and develop. And one of the things that I talked about with some of the students earlier was passion. And having that passion in what you do, to be the best at what you are going to embark on, to drive others, to engage others, to get others motivated, not only those that you work with, but to get others motivated to study engineering and science in the future. Because I really believe that is what is important in the end, is to inspire others that can build on your successes and create some of those opportunities that I think we all look forward to. And there's lots of ways to do that. There's lots of ways to give back. There's lots of ways to go back and I would say not only give to others. One of the things that I'm involved in, and it's purely an example, I'm in the executive committee for the Society of Chemical Industry. And every year what we do is we select a research scientist that has made some significant contribution to the world around us, okay? And we recognize them for their contributions, we recognize them from a monetary standpoint, but most importantly, we highlight them in front of the rest of the community to say, this is what can be done. As a matter of fact, last year we recognized the individual who's basically developed what seems to be a cure for leukemia in many circumstances. We also recognize the young scientist of the future, someone who's under 40, who's made significant contributions. We recognize maybe someone from industry that's created and done things for industry in the world around us that go beyond that. But more importantly, what we have done, we have set up a scholarship program where we reach out to the universities, in this particular case, throughout the United States, and we ask for each of the universities in the chemical and chemical engineering programs to identify individuals who they see and who volunteer for a summer internship with one of our companies. Now, we have internships on a regular basis, but this is a little different. This is a selection committee that's run jointly by the American Institute of Chemical Engineers and the American Chemical Society through the Chemical Heritage Foundation to go ahead and find kind of, quote, the best of the best of the best that want to do something. And they go through this whole screening process, and in the end, okay, they get an internship for the summer. They get a scholarship to help them go ahead and continue their education. And in terms of giving back and inspiring, we let them select, in most cases, a high school science teacher that inspired them to embark on a career in science or engineering. And they get to go back to that school and give them a $1,000 stipend to do anything they want in their class. Inspiration, the ability to give back, the ability to go ahead and drive that, I think is important in the world around us. And it goes beyond just all the basics that we learn when we're in school. And so what that allows you to do is really think about how you can spread your influence, how you can inspire others, but also in the workplace, how you will network, how you will drive others to think in the right ways. One of the things that I think you learn more about today than we did when I was in school, okay, is that ability to work together in teams, especially in cross-functional teams to solve more difficult problems. And that ability in the world around us and that ability to collaborate recognizes that we all, just as individuals, don't have all the answers. And we have to find ways to network, to work with others, to go ahead and come up with the ultimate answers to some of these issues and some of these situations. Another key thing is shaping the public dialogue. And one of the things that always bothers me is when I pick up a periodical, I watch a news broadcast, and I hear somebody quoting something that from a scientific standpoint makes no sense whatsoever. And we need the engineers and the scientists of the world to shape the dialogue so it's real. So we can really talk about some of these issues of the future and make sure that we address them, we develop them, we implement them, and we're able to benefit from them in the world around us. So in the end, you have the opportunity to be world changers. And that opportunity comes with the price of having to work hard and feel responsible and all those kinds of things that we talk about. But you have no clue as you set out from the school and you evolve as to who you might impact, who you might influence, and how you can respond to the challenge in meeting the world's needs around us. So today, I obviously did not want to get into facts and figures. I was not going to put up a bunch of flow diagrams. I sat down with 4 engineers from Purdue that actually graduated in the last 3 years, and I said, what should I talk about in this seminar? They said, first of all, no facts, no figures on the slides. Obviously, we didn't do that, okay? The second piece was, we talk a lot about technologies, but we don't talk about the interaction we see in the society around us. Some of these engineers now have had the chance to work in many parts of the world, okay? They've had a chance, okay, to work in Brazil. They've had a chance to go ahead and work in Indonesia. They've had a chance to work in Russia. They've had a chance to work in, obviously, a lot of places in the US. They've had a chance to go to the Dominican Republic, which is a business we started about 1.5 years ago, and get actively engaged in producing and moving medical oxygen into Haiti in the middle of the earthquake, when nobody else could get in there. Okay? And I had to get the State Department, the Department of Defense, and, okay, I would say the Dominican Republic government to go ahead and help us get in to do that. But these folks were at the forefront of it. They were driving that. And so their point was, we've got to find a way to get messages across so that people realize what we see today and what we can do and how we can go ahead and create that better world. And that's probably not what you learned in unit ops, and it's probably not what you talked about in thermo, and it's probably not what you learned about in fluid flow, but in the end, every one of those base technologies is what's necessary to solve these problems. So I thank you for your time. Let's talk a little bit. Questions, comments, advice from me.
Let's give opportunity first to the students to ask students, this is your chance.
All right. Very nice talk, first of all. So you're stressing out the fact that engineers and scientists are going to come up with a new breakthrough in technology. But what do you think about us as a community of engineers also trying to get involved in politics as well, trying to influence that? So unfortunately, country and all the policies are driven by unfortunately not very well made decisions. So you think that we should also think about getting involved in that area to make greater changes?
Yeah, I mean, I think obviously each individual's got to figure out what makes sense for them. But I think when you look at the dialogue, and if you look at what shapes the world around us, politics obviously is at the center of a lot of that. And you want to make sure that as decisions are made by elected officials, legislators, regulators, whatever the case may be, that those facts, especially when it comes to things like this, are rooted in hard science. They're rooted in the realities of the world. I mean, how many times have you sat through a debate where somebody quotes something on page 35 of chapter 6 in some report, and someone else quotes statistics from some other report, and they're totally different, right? And that would drive us nuts. I mean, what happens if you go into your thermo class and you know, someone has come up with the thermodynamic constant for something, and you're saying it's this, and you say, oh, I read in a book and it's really this over here. Well, that's going to go nowhere, right? Okay, and that's the harsh reality of the world around us, is that you want to get facts into the dialogue. And if part of that is being a part of that dialogue, part of that is driving the concepts, part of that is getting to the root, whether it's driving it through politics or volunteering or shaping that, I think it's critically important. I know I myself, okay, when I was 2 years out of Purdue, okay, I was reading something in the paper one day, and it was all about, at that time, we were still involved in the energy crisis of the time. It was the late 70s, going into the early 80s, and there were a lot of things being discussed about energy and how to produce power and doing a variety of things that just didn't make any sense to me, okay? And it's just the facts of it, the basis, it wasn't rooted in a scientific thought process, and it certainly didn't represent the reality of what I knew. And so I wrote my congressman a letter. I never expected a response. I never expected anybody to even read it. I was young, I was impressionable, I wrote the letter. I was sitting at my office 3 weeks later. I didn't give him my office number, okay? I didn't give him the address of where I worked. I just had my home address. I'm sitting at my office and the phone rings. And it's this congressman's assistant wanting to know if I was the Mike Graff that wrote the letter. And I said, I am. And the next thing you know, I had a half-hour conversation with the congressman. And I educated him on the oil business and refining and a variety of other things. So you can make a difference. At least I got the chance to go ahead and shape the dialogue in a different way. And there's lots of different ways you can do it, and I continue to do that today. I continue to do that not just because I'm trying to find a DOE opportunity for the company, but better, I'm trying to push, I would say, opportunity in a clear mindset of what engineering and technology can bring to the world around us. And believe me, people are really interested in knowing that. Once you get the chance to sit down with someone that doesn't have that knowledge and they recognize you possess it, they can't wait. They want to drink from a fire hose. They want to know what you know so that they can make better decisions.
The next question, I wanted to mention that we just yesterday, Mike, we have put up these banners for the school centennial. So I hope you will see these new banners here. So that's there are 17 companies.
Those are great.
Our centennial year. So the logos there, you see Liquide up in the front. Okay. All right. So next question. Yeah.
A lot of the things that we talked about with you, I think, as scientists and engineers, we tend to have a long-term perspective, I guess. We like slower moving systems with slower responding dynamics that we can trace and track and predict and know what happens when we kick it. And then you look at a lot of what happens in the world these days, and it's so fast, it's so dynamic, and the analyses that go on and back and forth are too rapid, too fast to really be reliable. I was wondering, as engineers and scientists, how do you think we can help shape public opinion in that regard to change the world to looking at things in a longer view?
I think the first thing that happens is vision. And I don't mean that in a short answer, but I mean that in terms of a long-term view of what we want to achieve. A lot of times when I look at the evolution, especially if you think about the quote of energy policy for the world around us and those kinds of things, it always seems really incremental. I mean, we say we want to reduce our demand for this or that on some long-term basis. But when you look at the actual perspective of what we're going to commit to this year and next year, it starts to feel very incremental. And I think the first thing, especially as scientists and engineers and with that long-term vision, is to help people visualize, to help people understand where we need to get to, okay? I have a vision, you probably figured it out, okay? That someday, under the right circumstances, and with those in this room and others that aren't here but are working hard at it, okay, we are going to provide and create a very efficient way to take the sun's energy, convert it to power, and use it. And we will probably take that and we'll probably use it not just to power things on the grid at that moment, but we'll find a way to store that power. I'm thinking through hydrogen. Maybe it's some other way. I'm not sure we can build a battery big enough to go ahead and power the city of Chicago. But anyway, we'll figure that out, okay? But I have a view that that's going to happen. Now, I may not live to see it, okay? But you need a vision that you can point to, that you can articulate, that you can get people excited about, and then talk about how am I going to get there? And how am I going to plan, and how am I going to develop the research? I mean, if I went back to that picture of 1979, I think it was, of Jimmy Carter, okay? And if at that point in time, we had taken just a fraction of the country's budget, and we gave it to the best and the brightest of scientists and engineers and said, I want renewable energy, where do you think we'd be today? I know we'd be a heck of a lot farther than we are right now, and I'd like to think we had solved the problem. And those are the kind of things that I think require that long-term vision, that energy. And sometimes you've got to be at that right point, both culturally and in terms of global impact, for everything to align the right way for people to finally say, okay, I've had enough. That is definitely where we want to go to, and it's time to make those commitments and make it happen. I mean, we did it with the space program, right? We said we're going to put a man on the moon in 10 years, and we did it. We really didn't know how that was going to happen. We didn't even have astronauts at the time. And all of a sudden, we're going to be there. And so I think that when you look at that and you consider everything that evolved and everything that happened, you first have to assert that long-term vision. It's got to be credible, but it's got to be far-reaching enough that it drives us to the place we want to be, and then clearly articulate that path forward. Now, that's easier said than done, and I realize that, okay? But that's how businesses are run. That's how people develop long-term strategy. That's how the world around us has evolved, is people have a vision to the future and they find a way to get there. They just don't say, I'm going to get better each year. That's important. I mean, you want to get better each year, but you got to have that long-term goal.
Okay, Jim?
Mike, it's really interesting. Some of the things you say about engineers getting involved in shaping the world. I think of the Dilbert cartoon series, which is, I think the guy who writes it actually was an engineer, that it gives a picture of an engineer as a somewhat arrogant, insensitive person who has all the answers but has no idea how to communicate them with or work with other people. Now, in your various roles, you must have a lot of experience in how to respect people from different backgrounds and how to work with them to achieve good things. I wonder if you have any advice for us as engineers about how to come out of a narrow mindset in order to influence and create change.
Right. You know, I think the first thing I would say is that if I think about myself, and I think about the class I graduated with, and I think about some of the students I met today, we're already 3 steps further than we would have been when I graduated. I see in today's world, I see students and graduates that are, first of all, much more conversant. They're much more in tune with the world around them. They're much more aware of the issues we face, okay? You know, some of us might have come out with more of a narrow perspective than where we were. We love the science, we love the mathematics, we love the engineering principles, and you didn't necessarily have to be a great communicator in order to succeed at that, right? In today's world, okay, if you really want to sell your ideas, if you really want to sell your concepts, okay, in the end, you've got to be able to communicate on them. And that's always been the case. But in reality, I think the first step, especially when you're dealing with a broad cross-section of people who may not have the same level of understanding that you have, is to first of all be a good listener. Before you start speaking, know your audience. Listen to them. Recognize who they are and where they're coming from, okay? The second thing is to recognize, yeah, we all don't think the same way. We all come from different cultures. We all come with different backgrounds. And maybe what excites and drives me might be a little different from the person next to me. It doesn't mean in the end we can't all reach to the same common good, so to speak, but you got to recognize that. And I think the third thing is, and this is sometimes hard for all of us that are engineers, because you ask me what time it is, and I want to tell you how to build that watch. And the reality is, especially with people that are not ready yet for the in-depth understanding of the technology and all the wherewithal that went into developing it, is having a clear, succinct message that is readily understandable, that catches their attention and allows them to understand what it is you're trying to deal with. And then you can broaden that once you capture their imagination on that. And that's the one thing that I believe that we have to continue to work on in modern society is our imagination. I worry a little bit at times. I had a chance, and for those of you that don't know it, and Arvind talked about some of my responsibilities with Air Liquide, and besides having responsibility for all the Americas, and we've got obviously a number of employees there, I actually have responsibility globally for all of our industrial systems and plants and those kinds of things. And it's all about safety. It's all about reliability. It's all about doing the right things, both in terms of behavioral safety as well as process safety, the way you design your plants, the way you operate them, the way you maintain them, and a variety of things like that. And I guess when you begin to look at that and you begin to think about safety in general and those kinds of perspectives, there are certain things that resonate with everybody. And you need to find those as you think about the perspective and how you're going to drive that. And so when you sit down with that group and you begin to think about what are the key messages and what are the key things that you want to drive, you've got to find that consistent message. And when I talk about safety, it captures everybody. And it's a way for me to link safety and reliability and cost and quality of everything we produce at one time. And certainly, if you're able to find those threads that people can have passion about, then you're able to go ahead and drive that message. So I think there's a lot of pieces to that, and I think that listening is probably the biggest piece.
In the interest of keeping things on time, I'll take this one last one. Okay, it is.
Since you are so closely involved with the carbon dioxide clean coal business, what's your vision about first the sequestration of the carbon dioxide and then the storage? Is there a chance that the second part can be solved also if the first one can be solved?
You know, I think that there's several aspects to that, and obviously when you look at the large quantities of carbon dioxide that are produced, there's not enough oil wells that are in decline to be utilized for enhanced oil recovery to consume and capture that CO2. And you also have a recognition that while some of that CO2 stays in the reservoir, some of it comes back out and you got to recycle it. You know, so you got this continuous recycle loop when you look at that. I think that the technology exists today to certainly capture the CO2 depending on how it's produced, okay? And I would say obviously, and it only makes sense, the more concentrated the CO2 is when it's produced, the more readily you can go ahead and further purify it, capture it in a more economic way. I think the challenge we all face right now is your point around sequestration. And that is, what is the right way to sequester that? And is that really the long-term solution? And I think that when we look at what we're trying to do with a saline aquifer, or you hear about people looking at ways to go ahead and store it in certain geological formations, or whatever the case may be, there's the initial question of how do I make that work from a science perspective, from a geological perspective. And then there's the question, coming back to the imagination piece, of what have I really thought about? Did I think about an earthquake when I developed that? Did I think about some of the other natural catastrophes that can occur, okay? And when I talked about safety before, and I use that as a common theme, this imagination piece is something when I spent a lot of time with NASA and trying to understand some of the things that occurred around the Challenger and the Columbia shuttle incidents, okay? And I did that because I was trying to figure out how do we, as a company, learn from a highly technical organization, one that has a lot of engineers working for it, to go ahead and ensure we drive that right safety culture in the world around us. And in those discussions, one of the things that even came out of NASA, okay, was this concept that we seem to have lost our ability to imagine things. We got so focused on this list of things we're supposed to do and thinking about, did I cover all those bases, which were things others had already thought about, that we lost our imagination to think about those things that could happen. You know, we don't know what we don't know, sort of a concept. And I think that's one of the key issues for us as we think about CO2 sequestration, is we've got to convince ourselves not only does it work today, but what are the things that can happen not just 10 years from now, but 100 years from now, to avoid having some sort of a problem. And I think in the end, one of the big issues is going to be who's going to take that liability? Who's going to say, I'm going to guarantee for the next 1,000 years it's going to be safe down there? And obviously the government's going to have to play a role in that if that's ever going to happen. So I don't know if that fully answers the question, but those are some of the issues I think we face in that regard.
Let us call the questions to an end. At 4:15, he needs to be in a car to take him to the airport. So, Mike, thank you very much for your talk and the question. Here is a small memento again.
Thank you very much. Appreciate that. Thank you. Thanks, everybody.